All right, so this module 1 stuff is all definitions. It's getting you introduced to statistics, that it is different than algebra. When I do this class, like statistics is not math class. Statistics is different. It's a different way of thinking. So when I try to do definitions, I try to make them real world definitions the way that I would just say it casually instead of like a mathematical definition. So like if you look it up on Alex or something like that, it may be different, but this is just the way that makes sense in my head. So I try to say things quick to get to you. So I might go through all the definitions real quick, and then we'll go work the topics, the example problems, because there's not a lot of writing that I have to do today. It's just definitions. And then we'll got a small activity at the end that kind of goes over one of them too. All right. So in statistics, our whole job, actually I'm going to start with this. I don't have it up here, but like the definition of statistics is collecting, organizing, summarizing data to make inferences. You don't have to write that down, but that's like our outline for the class. Like today we're going to talk about collecting. Next week we talk about organizing. The next week we talk about summarizing. And then it turns into making inferences. So what we do in statistics, or our job as statisticians, is to take the data and break it down for the non-math people to kind of show them how to do that. So what we have to do, and one of the big things that we do in this class, is the population sample. You hear these words a lot throughout the class. We can't possibly go ask everybody our question. So we'll make an easy example here. What if we were gonna, sorry, I try not to do like all sports references, but it's what's stuck in my head right now. If we wanted to go ask FSCJ all their favorite college football teams, and we had this, so we can't go ask all 25,000 FSCJ students who their favorite college football team is. That would be too hard, okay? We know it's to take too much time, too much money, and all those different things. But that would be our population. Our population is the entire group. We're basing this on the FSCJ students, so it's all of them. That's what the population is. We don't have the time and money to do that. So what we do is we go do a sample, a part of the group. Okay, we may go ask 100. We may go ask 1,000 even who their favorite college football team is. Okay, so let's say we go ask 100 FSCJ students just to get an idea. That is our sample. They use N. I don't have that on there, but they use N, the letter N, for like the number of people we ask a lot, like N equal 100. We'll talk about that a lot. That'll pop up. But N is the number of people we ask, or the number of data that we're surveying, different things like that. So we go ask 100 FSCJ students who their favorite college football team is, and 65% of them say Florida State, right? So 65% of them say Florida State. So what we can do, that's a sample. That's an actual statistic. We know for sure that 65% of the 100 people we asked this. So that is the statistic, the numerical summary of the sample. Like that's a fact. Like there is no debating that, okay? That's the data. We got 65% said Florida State's their favorite football team. But what we do with that information is we're trying to figure out what about the 25,000. So now we take that information and we apply it to the population of the FSCJ students, which is called the parameter. We're making a prediction. We could say, okay, based on our sample, we can assume or predict or infer that if we were to go ask all 25,000 FSCJ students, that about 65% of them, their favorite football team would be Florida State, right? No one's going to admit they're a Gator anymore. So you have this information. So like the statistic parameter, the S and P and P. Statistic has to do with your sample. That's true information. The parameter is a prediction, P and P, about the population. So like statistic, we actually know. A parameter is something we're kind of guessing at about the population. Okay. Here's your first hint at, and I know I'm zooming way in here, but I don't want to give you this answer. I know. You probably already wrote it down because y'all are writing, but I want y'all to think of this. So here's your first hint of how algebra is different, or stats is different than algebra. Okay, when you hear variable in math class, what do you think of? What? You think of like X, right? That's what you usually think of as X. Okay, we're not in algebra class. You got to change your mind a little bit. Okay. A variable in statistics is the data that we're collecting, like the information we're asking. So your favorite college football team, it'd be, Florida State, Miami, Florida, Georgia, whatever. Like it'd be whatever football team. Your favorite ice cream, the variables would be vanilla, chocolate, Rocky Road, Moose Tracks, whatever it would be, okay? Even if you did a number, your height, like if I measured everybody in this room, your height, it'd be 5'4", 5'5", 5'6", 5'7", 5'8", like those would be my variables. So the variables to me, and a short way to say it is the answer to the question, whatever kind of data we're looking at, okay? We can break these variables down into two different ways. Categorical is what Alex calls it. Sometimes it's called qualitative, is a category or a classification, okay? Your favorite football team, I could put it into, you could put all the Florida State fans here, all the Gator fans here, all that kind of thing. Your favorite ice cream, you can put the people who like vanilla here, the people who like chocolate here, strawberry there, okay? You can't do much with that information besides say what percentage of people like that team or that ice cream or how many, like that kind of thing. When you get into numbers like your height, I can say, hey, this person's like 5 inches taller than this person and different things like that. So categorical is the one way. That is usually a word. Like categories is usually words. Like freshmen, sophomore, junior, seniors. That would be a categorical one. Quantitative is the numbers, and the definition of this, and I know you can barely see it right there, but it's the numbers that you can add or subtract, and it makes sense. Okay, your height. If I had him stand on top of him, like they would be like 10 feet tall, right? Or 11 feet tall, whatever. I could say that she is 4 inches taller than she is. Like you can say these things, okay? So you can add or subtract those, and those make sense. Can you, and again, we're not in math class, so do not give me math words. Can you think of a number that if you add and subtract it in real life, it does not make sense? What'd you say? No, fraction. Well, fractions don't make sense. We know that, right? But no, that's math. That's math world. I want a number in real life. Like, don't think math numbers. Think of numbers that you come across with in your real life. I'm going to make y'all answer this, so y'all got to do it. I might give you a hint in a minute, but y'all got to come up with something. Okay? That's too mathy. Adding negatives and positives and minus and negative, that's no fun, but that's too mathy. We need numbers that you deal with in real life. 52%? No, not percentages. Percentages you can add or subtract. This item of clothing is 30% off. This one's 20% off, so that one's 10% off more. You got one? Zero. Too mathy. Y'all are too mathy today. I gotta break you out of this algebra. What mind? Zero does make sense because if I have one hat and he has 0 hats on, we got one hat together. So that does make sense. But no, that's too mathy. What, you got something?
An SSN.
Social Security number. Took me a second there, SSN. That's a good one. That is an example. So if I took my Social Security number and his Social Security number and added them together, it doesn't give me anything, right? That's not something that you're supposed to do, is add our numbers up, okay? Your Social Security number is a classification, or like when you were born or when you got your Social Security number or whatever. Now can you think of another one? Usually once you get one, they start coming pretty fast. Phone numbers, that's usually the easiest one. That's the hint I usually give. You can't get more than like 2 feet away from it. If we add our phone numbers together, it doesn't make any sense, right? Your cell phone now is a classification of where you got your phone. Anymore. Your user ID number, your S number, what you got?
Your bank account.
Your bank account. If we add our checking account numbers, the total amount would be like $2, right? No, but like our actual checking account number, it would not. That doesn't make any sense to add. That's a classification of how much money you have, I guess. I don't know. So the point of me saying this, the example that I have right here where I zoomed in that I didn't want you to see is zip codes. Like if we add our zip codes up, it doesn't give me anything new. Like your zip code is a classification of where you live. The reason I show you this is one, to break you out of algebra and get you out of math world. But two, categorical is usually a word and quantitative is usually a number. There are just few exceptions where if you add them up, it doesn't make sense. Okay. This section, level of measurement, I actually have deleted this topic, so I don't think I'm going to go over this. But it just kind of shows you real quick that you can break down categorical. You can kind of keep breaking down the variables and describing in different ways. So I guess I'll go over it for like 2 seconds. But there's not a topic on this one because I don't like it. Categorical, you could set them up to where they have no order, or you can make them like alphabetical order. You could put them in order or not in order. Like that's just kind of silly. Quantitative, this is really weird, and this is why I got rid of this topic, is like if the value 0 does not exist. So it's like interval. If I was talking about temperature, 0 is a temperature, right? But if I was talking about a weight, a baby's weight when they're born, 0 doesn't exist. Like a baby can't weigh 0 because then the baby wouldn't be there, right? So that's an interval versus ratio. Again, those get really weird, so I don't do those anymore. But another way you can break them down is discrete and continuous. Okay, the easiest way to do discrete and continuous is discrete you can count, continuous you measure. That's kind of the easy way to do it. The technical definition is that discrete is a finite number. Okay, what I mean by finite is there is an ending to it. It could be a big number. Like if a discrete number would be the number of if I went to all the classrooms in this building and started counting the students in each one, there'd be 25 in here, 28 in the other one, 14 in the other one. I can go and the only way to figure out how many students are in each room is to count them, right? It could be a big number though. If I want to go figure out the cars in the parking lot, the only way to figure it out is to count them. The stars in the sky, to figure out how many stars are in the sky, the only way to figure it out is to count them, okay? So it can be a big number even though it's finite, but there is an ending to that. You would get to the last car in the parking lot. You would get to the last star counted. Like you could, there is a finite number. Continuous is the easiest way to think about that is if you measure it, it's continuous. But there's an infinite amount of numbers that create when you measure things. This is kind of weird, but what do I want to do? Let's do cars traveling down Beach Boulevard. Let's do that, okay? 45 miles an hour. Like I can measure how fast the car is going if I had a radar gun and I can see how fast they're going, right? But if I had a really fancy radar gun, this car may be going 45.2 miles an hour and this car may be going 45.35 miles an hour, right? So if I had a really fancy one, it could give me an infinite amount of decimals that someone could be traveling. Same thing with your height. I talked about that a second ago. If you were 5'4", you usually just round it off, right? Nobody really says they're 5'4 and a half. Maybe like, NFL Combine or something. But like most people don't say that, right? But if you had like a laser, you could measure down to the thousandths millimeter of like how tall someone is. So it creates an infinite amount of variables. The weird way to think about that, and I don't know if I like this drawing, but we'll see. I've seen it before. This gets a little too mathy for me. Is discrete, you count. So it's like 1, 2, 3, 4. Whereas continuous, you measure. So it's like when I go count, it's like 1. What did I do there? When I write a bunch, I'll obviously get in a better position. 1, 2, 3, 4. Like I just count those numbers, right? But continuous, I can measure everything in between in those. So I can measure all those different ones. If that makes any sense. That's a little too mathy. But the easy way to do that, discrete, count, continuous, measure. All right, types of sampling. I'm actually going to skip right now because that's what our activity's on. So I will come back to that. All right, so just to go through a couple examples of these problems, to be frank with you, I usually use AI to come up with example problems for me. So if they don't match Alex perfectly, let me know. If they're a little wonky, I'll change them. I know all the stats topics, so I'll be able to change them before class most of the time. But if you ever do run into something and be like, hey, that topic's way different than what we did in class, let me know because I'll fix my notes. We'll go over it, whatever, okay? All right, so differentiating between parameter and statistics. Remember, parameter is talking about the population, and a statistic is talking about the sample. In a study of a town's population, the average age of all residents is 40 years, but a sample of 100 residents has an average age of 42 years. Identify which is a parameter and which is a statistic. Okay, the key word for population is all. When it says all, you're talking about the whole group, right? So the parameter of this would be 40 years old. The average age of all residents is 40 years old. The statistic is we did a sample of 100 people. That's my sample and the average is 42. So like right there, like this is why statistics isn't perfect, and this is what we do towards the end of the class, is we know, this kind of tells us that we know the average age is 40, but when we did our sample, we got 42. So at the end of class, we are trying to determine if like 42 is close enough to be a good number. Like, did we get a good prediction? And that's what we do towards the end of class. I'll probably just do like one example of each of these because they're not too terribly terrible. That's the sample one. That's what we're going to do our activity on, so I'll come back to that. All right, is the number of cars owned by a household qualitative, categorical, or quantitative? The number of cars, you can't add or subtract that and make sense, right? If this house has 5 cars and this house has 2 cars, they have 7 together, or 3. That car has 3 more, so that is a quantitative variable. Favorite music genre? That is going to be categorical, because I could put the people that like rap here, people like country here, people like R&B here, whatever. Discrete and continuous. The number of students in a classroom. The only way to figure out, that's the example that I did, man. The number of students in a classroom, the only way to figure that out is to count them. So it is discrete, okay? What's the other one? The height of a tree. The only way to figure that out is to measure it. So I got to go measure it somehow. So that is continuous. This one's pretty easy, but choosing units of measurements and appropriate method to gather data. Let's read it. To measure the length of a fish in a lake, choose an appropriate unit and suggest a method to collect the data. Okay? So to measure a fish, they did centimeters. We would probably do inches. And the best way to probably go do that is to actually go catch some fish in the lake and measure them to see how big they are. Anybody fish a lot? We usually talk about inches, right? We don't talk about centimeters. So that's kind of what these are, is like what kind of unit would we use? What's the best way to do it? These problems aren't too bad either. So you all see this first chapter you should get through pretty quick. Choose an appropriate method to conduct a survey. To estimate the percentage of city residents who support a new park, choose a survey method and estimate the sample size needed for accuracy. Okay, that goes a little too deep in that sample size stuff. So there's where AI makes that a little harder than it needs to be. But if we wanted to estimate the percentage of students who support our citizens who support a park, the best way to do that maybe is just to try to sample 100 people. You could do it by random phone calls in that neighborhood. You could do it by canvassing, walking around and asking them. If there's an old park, maybe you could go to the old park and be like, hey, do we need to update this? Okay, so those are all different ways that we could do that. What you have to be careful about in statistics, is creating bias. You never want to create bias in anything. There's several different types of bias. I don't think it goes too deep. This problem goes too deep into the way that, or what types of bias. But when you read a problem, you need to think about that. Like I just said, the park, if they're trying to build a new park, if I go to an old rundown park and start asking those people, hey, do you want a new park? Well, one, those are the people that go to the park and want to go to the park. And if they're, it's old, rusty, dangerous, hazard equipment, then they're going to be like, yes, we want a new park. Everybody's going to say yes. Like, why wouldn't we? We're the people that go to the park. We want a new one. Whereas other people in the neighborhood that don't go to the park may not want to spend tax money or whatever on that. So that is a little bit of a biased way to do that, is to go to the park and ask that. So let's do this example right here. A survey on exercise habits is conducted only at a gym. Identify the type of bias and suggest a way to reduce it, such as expanding the sample. Oh, well, you kind of gave me the answer there, AI. A survey of exercise habits is conducted only at a gym. Well, if I'm going to ask people how often they exercise every week, the best place to do that is probably not the gym, because those are the people that are exercising at least once a week, right? So that is called selection bias, because of where I'm selecting to do my data, or selecting to do my research. So a lot of these are just like, do you see something weird? Like, is there something weird that could happen with these problems? These can get a little bit tricky on Alex. Actually, let's pull one up on Alex and do it real quick, because I think one of these is tricky. And I'm going to go ahead and solve so I don't get it wrong. Ashley is a city councilwoman and an avid bicyclist. She wants to understand the opinions of the 235,000 people who live in the city regarding some potential items in the upcoming city budget. On her next ride with her bike club, she asks a member the following question: which project would you prefer the city to include in its budget? Building new bike paths throughout the city or renovating the basketball courts in the city's park? Of the 18 club members on the ride, 15 said they prefer a bike pass. So here's you can kind of think about this without looking at the answers, but if she's in a bike club and she asks the bike club members whether they want a bike path or a basketball court, obviously they're going to say bike club, okay? So the bias comes from the sampling done in the study. Ashley asks the questions of the member of Bike Club, making the sample of convenience, okay? We'll talk about convenience sampling here in just a minute when we do our activity. Describe something Ashley could have done to reduce the prominent source of bias in the study. The answer, I'll go ahead and read it. Modify the study in asking the question to random sample of people who live in the city instead of just a bike club. Okay? Almost every correct answer is going to have that random sample in it because we always want to do a random sample. We never want to do, a direct sample of like the bike club in there. You always want it to be random. You want to do different times a year. Here's my favorite example of this one of bias. I got a couple more I actually need to go over, but if I ask you, what is your favorite season? I've done this before in classes. What is your favorite season? How many of you all would say fall or winter? Okay, I'd say over half, right? Over half of you. If I ask that same question to my spring semester in January, you know how many people say spring or summer? Over half of them, okay? So because they're tired of it being cold. Right now, y'all are tired of it being hot, and you want the fall weather to come in, right? So when you ask the question can make a bearing on that. You ask the question at the end of the summer, people are tired of going to the beach. They want some cool weather, whatever. So when you ask the question can mess with that. How you ask the question, I guess I haven't done how you ask the question. I'm in my college football mode right now, maybe because Florida State was off last week. I don't know. But if I ask you what your favorite college football team is, and I say, is it the wonderful colors of garnet and gold, and they just renovated their stadium, and it looks great, and it's in the city's capital, and they have a great history of winning and all these things, or is it in that terrible town where there's one road and there's always traffic on it? Archer's literally the worst place on earth. And they literally play in a swamp. What's the point? The way you word the question can also mess with it, okay? Even the order of the questions you ask. If you're trying to do a serious question and you ask a silly question and then you ask a serious question, that can mess with people's minds. So you can kind of lead them to the answer. So there's all sorts of different bias like that you got to watch for. All right, activity time and then that last topic. I don't know if I need to write anything. Oh, I do need to write stuff for this activity. Okay. Yes.
The Gators won March Madness.
You a basketball school now? That's fine, I guess, if you want to be a basketball school.
More football, but
Yeah. I heard that on a podcast the other day. If you ask Gator fans what their favorite sports are, it's football, recruiting for football, and spring football. That's top three. But yeah, my wife's a Gator fan, so, I have to deal with it at home.
Go Dogs. Cold side.
Yeah. You didn't roll through Tallahassee very well, did you? That's fine. Okay. Before I get too off track here, I need you, while I talk about what I'm going to do right here, I need you to come up with a yes or no question that you wouldn't be embarrassed to answer in front of everybody because you're going to have to raise your hand or say yes, okay? Just a simple yes or no question. The one stipulation of the yes or no question is, one, don't make it embarrassing. Two, try to make it 50-50. If you ask, do you like cats? Everybody's going to say no. So, try to make it 50-50, okay? So, anybody got a quick yes or no question?
Do you like football?
Raise your hand if you like football. That's actually pretty close. As much as we've been talking about it today, that's not bad. Okay. We'll roll with it. I've never done that one before, so let's see. Okay. So what we just did there is come up with a question. This section's all about collecting data. We are saying, do you like football? There's different ways to sample. You always want to do a random sample. So you saw me pull up the random number generator right there. So that's the first thing I need to do is number you off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 behind the computer right there. 15, 16, 17, 18, 19, 20. Did I skip you? I think I skipped you. 20, 21, 22. I'll be 23, okay? So you have a number. So the best way to do it is a random simple or a random sample. So the first way that we sample people is a simple random sample. Okay, I believe all these definitions are at the top of the page. Simple, yes. Okay. The thing about a simple random sample is you have a equal chance of being selected. So I'm going to go to my random number generator here. 1 and 23 is what we're picking. When your number pops up on the screen, you are going to say, do you like football? Yes or no? Just yes or no, okay? Can you tally for me?
Yeah.
So this is my population. My population is all of you. So we are just going to do a sample of 5 people, okay? Because that's part of the population. So we're doing a sample of 5 people. So stop me when I get to 5 and then tally yes or no for me. 16. You were 14, 15. I think you were 16, weren't you?
Yeah.
Yes or no? Do you like football?
Yes.
Okay. If your number pops up twice in this round, don't answer again, okay? 20. Do you like football? Yes or no?
No.
8.
Yes.
9.
No.
18. What were you, 16? I think it's the green water bottle right here. Yeah. All right, what'd you get there?
3 yeses and 2 nos.
Okay, so we did a simple random sample. We got 3 out of 5. That's 60%. So I can go write a study and be published in journals and say, hey, 60% of FSCJ students like football, okay? This is a valid study. We use simple random sample. Everything we did is legit right there, okay? So that's one way. That's the most common way to sample, whether it's a simple random phone call, simple like ID number drawing, like whatever it is. The next way is going to be stratified. Okay, stratified, we are going to split into groups and randomly ask people from each group. And again, I believe these definitions are at the top. I'll go back up there in a minute. But stratified, you split into groups and you randomly ask people from each group. So the easiest way to do this is just to go ahead and do, let's do like 1 through 12 and 13 to 23. That's about even, okay? So we're going to do the same thing. Ask 5 people when your number pops up, do you like football, yes or no?
Yes.
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 No.
All right. That was 5.
Okay, so that one we got 4 out of 5. 4 out of 5 is 80%. So again, I kind of have a study right there, but let's go ahead and do the other side real quick. 13 to 23. 16.
Yes.
Yes, that's me. 15, you. Yeah, you.
No.
13.
Yes.
20. You can say no. Yeah, you can answer again this time. 18.
That was 5.
Oh, we already got 5? Okay. How many?
3 out of 5.
3 out of 5. Okay, so that's 60%. So if I want to, combine these and say 70%, put them together because I did a sample from one group, I did a sample from another group. So stratify, you split them into groups and you randomly ask people from each group. So again, I could go write a study and I have 2 different numbers now here. So I go look at one website and it says 60%. I go look at a different website, it says 70%. And it's all based on the same set of data right here. Okay, another one is called cluster. Cluster is like stratified because you split it into groups, but instead of asking people from each group in cluster, let me say it in one quick definition if you're writing, you split into groups and you randomly pick one group and the entire group answers, okay? You split into group and you randomly pick one group and the entire group answers. So, the best way to do this in this classroom. I'll do every 2 rows, okay? So let's pick a number. First 2 rows is one group, second 2 rows is one group, third 2 rows, and I'll be in the first group since there's only you 2. Okay, so let's generate The third one, oh my goodness, now I'm confused myself. 1, 2, 3, 4. This group, starting with this row, so tally these for me.
Yeah.
No. 3 no's.
Yes.
Okay, so what was that?
That was 2 out of 5.
2 out of 5. So now I can go write a study and get it published and all these different things and say, hey, only 40% of FSCJ students like football. Okay? This is how, like, data gets confused across. You watch one channel all the time, you watch a different channel, you get 2 different numbers. We're talking to the same group of people. Imagine if you had 100,000, how many different numbers you could create, okay? So this is where the people can just do multiple studies and pick whichever number they like and to fit their narrative. All right, the last kind of way is systematic. This one you've heard of. This is like asking every third person or every fourth person or every fifth person, something like that. So we will randomly pick a number between, I don't know, 2 and 5. Oh, we'll do 2 and 6. 5. So I'm going to ask every fifth person. So tally these for me. You can start. Yes, you were yes, right?
Yeah.
1, 2, 3, 4. Yes or no?
No.
1, 2, 3, 4. 1, 2, 3, 4. No, brown shirt. 16.
Yes.
1, 2, 3, 4.
Oh, yeah. All right. So 4 out of 5.
4 out of 5. So that one we got 80%. So do we get? So we did this 4 different ways, and we got 4 different numbers. We got 60, 70, 40, and 80. Okay. Just by doing this. So again, imagine if you go ask 10,000 people how many different ways you could create it. The only other way that I didn't put up there, I'll come back to these numbers in just a second, but just to see the definitions, there they are. The only way I haven't talked about is convenience sampling. This would be like, we talked about football, so this would be like if I went and stood out Jag Stadium and said, hey, do you like football? As they're walking in to watch a football game, I'm going to get probably 100% around it, right? So this is like convenience sampling, just doing what's easily accessible, but it's not really reliable. All right, so those are the different ways to sample. In Alex, when you do this topic, it does like italicize the words that are important, so like pay attention to those. And the big ones that confuse you are stratified and cluster. Stratified, you split into group and you ask people from each group. Cluster, you split into groups and you randomly pick one group and ask that entire group. All right, so convenience. So people that are interested in this always say, okay, so what's the best way to do it? The number one best way to do it is a census. This is what the U.S. tries to do every 10 years, right? And that's to ask the entire population. Okay? To ask the entire population. Even when they do a census every 10 years, they can't get everybody to participate. So that's the one true way to get the answers, to just, no matter how much money or time it takes, to ask everybody. All right. Raise your hand if you like football. Let's count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's break out the calculator here. 13 divided by 23. The true number is 57%. So my true number, we know, is 57%. Okay, so that's the true number. We are using samples to try to guess what that number would be, because you can't usually ask the population like we're doing in this class. Okay, simple random sample looks like it worked the best. But since censuses cost too much time, take too much money, the best way to do it is to do these samples over and over and over again in different ways, and then kind of look at the numbers. So just out of curiosity, I have no idea if this will work. Probably won't work perfectly, but if I found the average, I know we haven't talked about average yet, but y'all kind of know what the average means. If I found the averages of these 4%, the average of these is 62.5. So if we did it over and over and over again, we would get pretty close to it, right? So my average right there. So that is the best way to do it, is to do it over and over again, do it different times of the year, do it different ways, and get your answer right there, okay? All right, so that is a quick... Wait, let me finish this, because I said I'd do one of those. That's a quick activity on the different types of sampling. That's what I mean when I say that we may do some activities in class. They'll be pretty quick like that. Okay, so I'm not going to read all this to you. We'll figure out the easy way to do this. A, it says stratified right there, right? Actually, I'll just screenshot this real quick. Oh no, it took away my answers. All right, stratified sample right here. So I think it was C. The botanist forms 4 groups of plants based on the age. Then he selects 16 from each group. Okay, so forms 4 groups into 4 groups. That's my answer. Next one is convenience. I would say the key word right here is easily accessible. The mice crops in the first shipment that was received are easily accessible, so he selects all 54 in this shipment. When you see words like that, when he makes it super easy on himself and does not actually do a random one, that's what happens there. The last one is cluster. So we're looking for split into groups, form 5 groups, and then selects 18 seats from each group. Nope. Form groups of 30 seats, and then selects all of the seats in 3 randomly chosen groups, okay? So that's the difference. In stratified, you split it into group and you ask people from each group. In cluster, you split it into groups and you randomly pick one group to do it. All right.